In this lesson, we will talk about text input output. Previously, you might be used to reading things from a keyboard using a scanner object and using system.in. Here we extend the concepts to files. So with files, there's a notion called the absolute file name, which represents the complete file name. Something like this in Windows, where it includes the directory or folder you happen to be in, also the file name, and something like this in Unix and Mac world, where you have the folder and the file name. Windows using backslashes and Unix using forward slashes, right? So there's obviously the directory path in each case, and then there's actually the file part of it. Okay, there's also the notion of a relative file name, which is relative to where you currently happen to be, the current working directory or current working folder. So if you happen to be in users Joe, the relative file name would be the rest of the folder path and including the file name, right? The file class in Java provides an abstraction over all the machine-dependent Windows Unix complexities of dealing with files and directories. It provides you methods for accessing the properties of the file, deleting files, renaming files and folders, right? Interestingly, it does not provide methods for reading or writing the file contents. You have to do it in a different way, right? The remaining thing you should be aware of is try to use forward slashes just to be uniform across Windows and Unix. All right, so what methods does the file class provide you? The methods it provides are to check if the file or folder exists, whether it's actually a directory or folder, whether it's a file. Is it readable? Do the permissions allow it to be read? Is it writable? When was it last modified? And the current size of the file, right? So here is an example where I have a hypothetical data.txt file, and I am using all of the methods here. So actually, let's just copy this and run it and see what it shows. We'll open it, type it up in a blank IntelliJ. Now, do note that the file that it refers to, I have actually created. It is nothing, just contains some numbers. So that's what we are working with. And if we run it, we'll find some interesting data. The file does exist. It is a file. It is not a directory. It can be read, can be written to. The last time somebody tried to get to it, and the current size, about 7 bytes long. Okay, so now let's return to, and this is what I show here as well. Okay, so let's talk about reading stuff from files. So just like we read from keyboard, we can read text data from files using a scanner class, right? The scanner class, the way it works, it breaks up input into tokens that are delimited by white space. So white space is anything such as tabs or space and new lines. That's all considered white space, right? To read things from the keyboard, as we know that we declare a new scanner object and we provide system.in as the source of the input. To read things from a file, you would replace system.in with the file object. Now, where are you getting this file object from is the one that we declared here, new file. And what we provided it was the full path to get to the file, right? So that's the file object. Okay. Now, interestingly enough, while you're using system.in, you were okay. But now, as soon as you do this, you will be required to add throws declaration to your method, your calling method, right? And so now your main will have to be appended with throws FileNotFoundException. Why is that? And the reason is the scanner constructor, this constructor, the one that takes a file object, may throw FileNotFoundException. And as FileNotFoundException is a checked exception. You have learned that in the exceptions lesson. it must be explicitly declared, and that's why you're required to. That's why, you might be wondering, why is it forcing me to declare a FileNotFoundException? And that is the reason. Okay, so actually, let's actually go ahead and prep our file for doing that. So we'll go ahead, and at the end of it, we will say, okay, this file, if you got properties of, I am going to read something, and I'll need the class. Now, if you look at this, it is going to complain. If I hold it on there for a little bit longer, it is going to complain that there's unhandled exception, file not found exception, right? So we'll have to go ahead and declare that. I think it lets me do it automatically if I do that. Lets me add that to the signature, right? So now it's good. It's added all the right things. Okay, let's back to the lesson. So how does all this reading, all the reading methods work, right? So we are reading basically tokens, right? And Scanner gives us a bunch of token reading methods, such as next byte, next short, next int, next long, next float, next double, right? It also it gives you next, which is like the string version of it, right? So it reads the next little bit till it sees a delimiter. A delimiter is essentially white space by default, but you can also change it to be something else. You can change it to be a comma or a semicolon. If you're dealing with CSV files, you might have done that, is used a semicolon, right? This is actually a regular expression. You can kind of make it fairly complex, right? So all of these methods work in this way, and it's important to understand this. First, they will skip any delimiters that they might be at. So, and then they will read the next string token that ends with the next delimiter, right? And the next thing is then they will convert it to the type that you're looking for. So if you happen to be using next int, it'll convert whatever string token it read to int, right? And if it can't be converted, you will get an input mismatch exception raised, right? That is how they work. They're all reading some location. There's some point in a file. And they will first skip all the white space, and then as soon as they're done with the white space, they read the next bit of characters and form a string token till they get to another delimiter. They try to convert based on the method that you are using, and give you that value. If they can't do that value, an input mismatch exception is raised. If you're using next, the string version of it, no conversion is performed, right? If you're using next line, it'll read the whole line, right, till it gets to a line separator. A line separator is basically a new line character, right? So this is how it works, and let's actually try this out. So let's actually take a look at what happens in the following situation, right? We are reading from the file. We are reading an integer followed by a text value and printing each of those out. And so let's say our file contains this, right? Let's see what happens. So let's go ahead. I'll copy this bit of code and we'll actually try this out, what is happening. So right below here, we will add that. And it's reading from our file here. Let's take a quick look at the file. The file basically contains 1, 2 space, which is a delimiter, and 3, 4, 5 new line, and that's where it stops. So let's run this and see what happens. So we'll run it. Now, interesting thing, it's read 12 for the integer. But interesting, it's read space 3, 4, 5 for the string, right? So there's an extra space there. You'd be wondering what happened there. I was reading next int followed by next line, right? And so, how did this all work? So basically what has happened, and if you let's go back to this thing, is it kept on reading next int, so it kept on reading and got a token which is 12 till it hit the next delimiter, which was a space. Said, okay, it's int, so I'm going to convert it into an int. It was able to convert it, looked like an int, and that's what it returned. Then it was left here, the cursor was left here, and kept on reading next line till it got to the end. Now, since it was next line, it didn't skip the initial white space and just read from here till it got to the end of the line and picked up and returned whatever was there. So that is why you got the extra white space, right? Now we could look at another version of this, which reads from standard input and not from a file. So we can just go ahead and replace this part in our code, and we'll try to do the same thing. Let's say we will enter 12, press the enter key, and then plan to press 3, 4, 5, and press the enter key, and see what happens there, right? So let's go, and we will replace this here with, now we're ignoring the file object, and let's run this. Right, now it's actually waiting for me to enter something, so I'm going to say 1, 2, enter, and then strangely enough it finished. It never gave me a chance to even read 3, 4, 5. So what exactly happened here? Let's look at it, right? So as I say, what's happening is the next int reads the 12, right, but stops right before the delimiter, which is the enter key that was is also considered a line separator, right? So it hasn't read the enter key, and then next line reads from where it was left till the line separator, which includes the enter key, and returns that, which is basically the empty string. So now int val has 12, but the text val is just an empty string, right? That is how that was read. So both these examples explain how these things work. Okay, moving on. Testing input, you might be familiar with it. We can test the input before it's read using the has methods. hasNext will check if there is more data to read. It's a good way of checking whether you have reached the end of file, right? And there's hasNext int and hasNext double, which additionally checks the type of something, right? So you can check that before you actually read it, otherwise do something else, right? Additionally, you should already be familiar with converting strings into particular types. So here I give two examples. The first one is a string that contains 1, 2, 3, and I am using the class version of the integer object to parse it as an integer, right? And this will make this 1, 2, 3. And then here I'm giving an example of a double, right? Now the question might be is what happens if these don't represent valid numbers, right? And in both cases, you'll get a number format exception. So we can actually pick one of these and try it out in code. So we can actually get rid of all of that and actually just try this out. So instead of, if you do this, you will get a nice number, but suppose you enter a at the end of it, now it's like a bad string, and do that, you should get a very nice number format exception. All right. So this lesson has been on text input output and how it relates to exceptions. That's the related lesson that we referred to. Thank you.